Let us. Okay, once again, I welcome all the participants for the day 4 lecture of Research Scope online series Research Scope in emerging areas of civil engineering, organized by Aditya Learning Academy in association with the Department of Civil Engineering, Aditya University. I welcome all the participants on behalf of our department. I am Dr. S. Ananda Kumar, Assistant Professor in Department of Civil Engineering. Today, I am going to give a presentation on ground improvement techniques, mainly focusing on the biopolymer amended soils. So this is the contents of my presentation, starting from the introduction to ground improvement techniques, its objectives and its overview and its challenges will be given initially, followed by biopolymer amended soil and its index properties, engineering properties, followed by microstructure analysis and a small application for the biopolymer amended soil. Today I have selected is liner material. It's my research topic also. So followed by future scope for research of this biopolymer amended soil also will be given. So then it will be concluded. So let us start the presentation now. So it is introduction to the ground improvement techniques. What is meant by ground improvement? So ground improvement is a technique which is used to enhance the soil properties. So why we need to do ground improvement? Nowadays, due to urbanization, many people are moving from villages to towns and cities. So there is a huge populations are there. Due to the population crowd is more, we are going to because of that many apartments, many buildings are constructed in the cities. Already available lands are already occupied. So in this scenario, we should not omit any land by saying this land is not suitable for construction. So whatever the soil may be, we need to use our engineering techniques to improve the soil, and then we can able to construct even up to some heavier structures. So the ground improvement techniques is very much necessary. So why we need to do means already it is very clear that we need to enhance the soil properties. If you are enhancing the soil properties, it will ensure the stability of the soil and structure. So if you are doing the ground improvement, it will increase, mainly it will increase the bearing capacity of the soil and it will decreases the settlement of the particular soil and it will support the heavier structures also. If you are doing properly, it will support up to heavier structures also, so that it will reduce the risk of failures and then safer and durable structures will be constructed. So these are the benefits of this ground improvement. A short introduction also. Objectives of the ground improvement. So if you are doing the ground improvement techniques, we mainly it is used for the construction projects. So if you are doing these things, first thing, it will increase the load bearing capacity of the soil. So we will start from the introduction to ground improvement techniques. So why we need to do ground improvement means nowadays due to the urbanization, people are moving from villages to towns and cities for their occupation. So the spaces available in the city, which is okay. Introduction to the ground improvement techniques. We'll start from this again. Sorry for the interruption. So now everything is clear. We'll start from the introduction to ground improvement techniques. So first, what is meant by ground improvement? Why we need to do it means due to the urbanization, we need to move from village to cities to for their peoples are moving for their occupation. So for that, nowadays, almost in the metropolitan cities like Chennai, Hyderabad, Mumbai, it is already occupied with all the lands. Already all the lands are occupied. Very few lands are available. So like this, in many areas, few areas are available. So we should not omit any land because by saying that the soil is not suitable for construction. So we can improve the ground by the engineering, civil engineering techniques, that too especially the ground improvement techniques to increase its bearing capacity, and we can construct the buildings on it. So this is the purpose of the ground improvement. And the importance of ground improvement is that essential, it is addressing the soil issues to ensure stability. So it is not only for uh, urbanization purpose, in terms of civil engineering, in terms of ground improvement techniques, it is very essential for increasing the bearing capacity of the soil. So if you are doing the ground improvement, the bearing capacity will be increased, and then the settlement of the building will be decreased. The soil structure will be stable. So if you are doing, so now it is very clear that we are doing ground improvement for enhancing the bearing capacity of the weak soil and to reduce the settlement of the building. So this ground improvement technique is mainly suitable for the construction projects. Next, the objectives of the ground improvement. As the key goals for construction projects, it will increase the load bearing capacity, enhancing the soil's ability to support structures, ensuring safety and longevity, and it will reduce the settlement. That means minimizing the risk of uneven settling of buildings, preventing structural damage, and then it will enhance the stability of the building. That means improving the resistance to sliding and erosion for better structural integrity. So now we came to overview the ground improvement techniques. So what are the ground improvement techniques are available? Let us see. So the first one is compaction. The second one is grouting technique. Third one is soil stabilization technique. Fourth one is reinforcement for structural support, and then preventing structural issues. So compaction. Well, compaction, if you are doing, it will increases the density of the soil, and thus it will provide more load bearing capacity and stability. Grouting means, in the grouting technique, we will just inject a fluid or any additive to the soil, and it will fill the void spaces in the soil, so that it will enhance the soil strength and it will reduces the permeability of the soil. Likewise, soil stabilization techniques, it is a major topic in the ground improvement techniques. So the soil stabilization techniques will modify the soil properties by using some additives, ensuring better performance under load. Next one is the reinforcement techniques. Already the weaker soil will be reinforced with the some reinforcement materials like geogrids, geosynthetics. Likewise, we will provide some reinforcement and we will increase the shear strength of the soil. So as well as the preventing structural issues will also, this technique helps prevent settlement, slope failure and liquefaction, safeguarding the structural integrity of the building. Next one. So these techniques, now we are going to see one by one. Soil compaction methods. In soil compaction methods, first we need to understand what is the soil compaction. If you are doing soil compaction, it will reduce the air voids which is present in the soil mass. So if the air voids are reduced, the soil dry density, that means the density of the soil will be increased. If the density of the soil is increased, what will happen? Then the load bearing capacity will also be increased. Next one, dynamic compaction. So in the compaction, we will use dynamic compaction, static compaction. So dynamic compaction, this method we are using, in this method, what we will do means we will apply the heavy weights. That means we will drop the heavy weights onto the soil to achieve the compaction. Next one is the static compaction. So we will use heavy rollers. These heavy rollers will compress the soil layers and thus it will enhance the stability of the soils. Next one, what is the benefits of this compaction? It leads to reduced settlement and it will improve the stability for the structures. Next one is the grouting technique. As we already discussed in the introduction slide, grouting techniques means that we are going to inject some fluid, that means any additives in the fluid form to the soil. So first one is the cementitious grouting, which uses the cement based material to fill voids, improving soil strength and stability. And the second one is chemical grouting. So in the chemical grouting, we will use the chemical solutions which will react with the soil and to form the solid masses. So the solid masses will enhance the soil properties and thus the shear strength will be increased, the permeability will be decreased. So this kind of properties will be changed. Next one, in the highway project, just I have mentioned these techniques we can use in the highway project. So cementitious grouting in a highway project reduced settlement and boosted load bearing capacity. Next one, ground improvement methodologies. So in this ground improvement methodologies, I'm only talking now. We are talking about the soil stabilization methods. In the soil stabilization methods, three methods are there. One is the mechanical methods, and on the chemical methods, as well as the physical methods. In the mechanical methods, we will use technique like dynamic compaction or vibro compaction to enhance the soil properties. But in the chemical methods, we will mix the some of the chemicals like lime, cement, or polymers to chemically stabilize the soils and to enhance its properties. Physical methods, in the physical methods, we will incorporate excavation and will totally replace the soil or drainage techniques to improve the site conditions. So this soil stabilization methods is especially we need to is different for different site conditions and it is depend upon the project budget also. We need to concentrate on the environmental impact. When we are doing this, when we are applying this ground improvement methodology, we need to assess the site condition and budget consideration should be there, as well as the environmental, the impact. If you are using this chemical method or mechanical method or physical method, we need to carefully assess the environmental impact. If you are following this method, what are the environmental impact will come? So generally used chemicals are, that means conventional chemicals which we are using for the available soil stabilization are lime, cement and bitumen. So generally we will use lime for clay soils, which will reduce the plasticity of the soil, clay soils. If we will use the cement for weak soils so that it will increases the strength of the particular soil. We can use the bitumen to increase the for the granular soils to improve the water resistance. Next one is the reinforcement techniques. So in the reinforcement techniques, we will use the geogrids or soil nails or geotextiles. So just imagine that we are having a weak soil or loose soil. So if you are applying the load on the weak soil or that loose soil, what will happen? The soil, the strength won't be there, and the sudden settlement will be there. The soil will get fail easily. So imagine a 5 meter layer of soil. We are fixing the geogrids or any nails every 0.5 meter, and then we are applying the load. Means this will behave like reinforcement and it will give more strength to that particular soil. So we can construct some heavy load structures also on that particular area. So first we will see about the geogrids. These are the polymer grids that will distribute the loads and minimize soil settlement and enhances the stability of the soil. Next one is soil nails are seems to be like steel bars which will inserted into the slopes of the soil layers so that to provide the stability. It not only provides the stability, it will stop the erosion. That means it will prevent the erosion also. Next one is the geotextiles. So geotextiles are various. It's a type of fabrics. Woven and non-wovens are there. Many types of geotextiles are there. It is a separate topic, but we are using the geotextiles for the purpose of enhancing the drainage as well as to stop the soil erosion immediately. Next one is the sustainable ground improvement practices. So whatever in nowadays in the engineering practices, the researchers are mainly focusing on the sustainable materials. So now we are looking in the ground improvement practices. So in ground improvement practices also, we are going to use some additives or some materials to increase the strength of the soil, to decrease the permeability of the soil, whatever it may be. Now researchers are completely focusing on the sustainable materials. So how this sustainable is linking to the ground improvement practices means researchers started to use the recycled materials. So our this practices should limit the disturbing of the soil, and the erosion control measures also needs to be considered. So so till now we have discussed 4 5 methods of ground improvement techniques, in which how to select the particular thing. So it should be cost effective, it should be time efficient, as well as it should be a sustainable material. It should give more load bearing capacity when compared to the untreated soil. After treatment, the particular soil should give more load bearing capacity. So likewise, we need to choose the ground improvement technique. Okay, we are doing the ground improvement techniques. Next, if you are using the ground improvement techniques, what are the challenges we are facing? So in every research, we are having the limitations. So if you are doing any tests which are limited to the particular environmental condition, particular load rate, likewise, till now some methods are in the research stage. So the technical limitations are available for the ground improvement techniques, often face technical constraints that limit effectiveness. Next one is the environmental impacts. So while choosing any material, we need to focus more on the environmental impacts. So
Nowadays,
nowadays
people
people
stopped
stopped
the
the
utilization
utilization
of
of
cement
cement
for
for
treatment,
treatment,
and
and
they
they
are
are
looking
looking
for
for
alternative
alternative
materials.
materials.
So
So
many
many
biomaterials
biomaterials
came
came
into
into
the
the
picture
picture
now,
now,
like
like
biopolymer,
biopolymer,
biochar.
biochar.
So
So
many
many
um,
uh,
biomaterials
biomaterials
came
came
into the
into the
picture
picture
in the
in the
ground
ground
improvement
improvement
techniques.
techniques.
Next,
Next,
we are
we are
looking
looking
into the
into the
environmental
environmental
conditions,
conditions,
but
but
what
what
about
about
the
the
economic
economic
considerations?
considerations?
We
We
can
can
choose
choose
any
any
material
material
as
as
a
a
biomaterial.
biomaterial.
If
If
its
its
cost is
cost is
more,
more,
means
means
what
what
will
will
be
be
happen?
happen?
So we
So we
need
need
to
to
this
this
economically,
economically,
the
the
technique
technique
should
should
be
be
economically
economically
also
also
benefitable
benefitable
to
to
the
the
clients.
clients.
Next
Next
one,
one,
regulatory
regulatory
hurdles
hurdles
are also
also
there.
there.
So
So
we
we
need
need
to
to
concentrate
concentrate
on
on
that
that
also.
also.
That
That
means
means
we
we
need to
need to
focus
focus
on the
on the
regulatory,
regulatory,
government
government
regulatory
regulatory
for
for
using
using
that
that
material or
material or
for
for
the
the
technique.
technique.
Next one
Next
is
one is
the
the
site
site
specific
specific
challenges.
challenges.
So
So
all
all
ground
ground
improvement
improvement
techniques will
techniques will
not be
not be
suitable
suitable
for
for
a
a
particular
particular
site,
site,
for
for
all the
all the
sites.
sites.
So
So
site
site
specific
specific
challenges will
challenges will
be
be
there.
there.
Next
Next
one,
one
like
like
stakeholder
stakeholder
engagement,
engagement,
technological
technological
advancement,
advancement,
and
and
project
project
management
management
for
for
this
this
ground
ground
improvement
improvement
technique.
technique.
These
These
are
are
also
also
a
a
greatest
greatest
challenges
challenges
for
for
the
the
geotechnical
geotechnical
engineer
engineer
who is
who is
handling
handling
that
that
particular
particular
project.
project.
Next one
Next
is
one is
the
the
major
major
challenges
challenges
when we
when we
are
are
dealing
dealing
with
with
the
the
ground
ground
improvement
improvement
projects.
projects.
So the
So the
first one
first
is
one is
the
the
soil
soil
variability.
variability.
It
It
is
is
we
we
cannot
cannot
predict the
predict the
soil
soil
condition.
condition.
It is
It is
unpredictable,
unpredictable,
which
which
can
can
complicate
complicate
improvement
improvement
efforts,
efforts,
leading
leading
to
to
unforeseen
unforeseen
project
project
delays.
delays.
We
We
will
will
expect
expect
something.
something.
We
We
will
will
have
have
some
some
equipments.
equipments.
After
After
drilling to
drilling
a
to a
particular
particular
depth,
depth,
we
we
will
will
find out
find out
some
some
other
other
rocks.
rocks.
So
So
based
based
on
on
that,
that,
we
we
need
need
to
to
change
change
our
our
tools
tools
for
for
drilling.
drilling.
For Likewise,
Likewise,
many
many
unpredictable
unpredictable
soil
soil
conditions will
conditions
be
will be
there.
there.
So
So
that is
that is
the
the
first
first
major
major
challenge,
challenge,
as well
as
as
well as
already
already
discussed
discussed
technical
technical
limitations
limitations
are
are
there,
there,
environmental
environmental
concerns
concerns
also
also
there.
there.
Also, we
Also, we
need
need
to
to
concentrate
concentrate
on the
on the
budget
budget
of the
of the
project
project
also.
also.
Next one
Next
is
one is
the
the
it
it
is
is
like
like
area.
area.
For
For
example, if
example,
you
if
are
you are
taking
taking urban
urban
areas,
areas, we
we
can
can
see
see
more
more
unstable
unstable
clay
clay
soil.
soil.
So
So
for
for
that,
that,
what
what
will
will
happen?
happen?
Delays
Delays
will
will
be
be
happen
happen
due to
due to
the
the
insufficient
insufficient
compact
compact
methods.
methods.
If you
If
are
you are
taking
taking
coastal
coastal
infrastructure
infrastructure
areas,
areas,
liquefaction
liquefaction
will
will
be
be
happen
happen
during
during
the
the
earthquakes.
earthquakes.
So
So
due
due
to
to
that
that,
structural
structural
damage
damage
and
and
necessitated
necessitated
redesign
redesign
should be
should be
done.
done.
If you
If
are
you are
taking
taking
road
road
construction, the
construction, the
major
major
challenge
challenge
we are
we are
facing is
facing is
that
that
high groundwater
groundwater
levels.
levels.
If
If
high
high
groundwater
groundwater
levels
levels
are
are
there,
there,
we
we
need
need
to
to
spend
spend
more
more
cost
cost
for
for
drainage
drainage
solutions.
solutions.
So
So
the
the pros
pros
and
and cons
cons
of the
of the
ground
ground
improvement
improvement
techniques
techniques
till
till
now we
now we
have
have
discussed
discussed
is,
is
if you
if
are
you are
going
going
for
for
compaction,
compaction,
the
the
pros
pros
are
are
low
low
cost,
cost,
it will
it will
give
give
quick
quick
results,
results,
but
but
it is
it is
limited to
limited to
the
the
effectiveness in
effectiveness in
the
the
saturated
saturated
soils.
soils.
Limited
Limited
effectiveness in
effectiveness
the
in the
saturated
saturated
soils.
soils.
Next one
Next
is
one
the
is the
grouting
grouting
technique.
technique.
It will
It will
improve
improve
the
the
load
load
bearing
bearing
capacity,
capacity,
but
but
it is
it is
high
high
cost.
cost.
It
It
requires
requires
skilled
skilled
labor.
labor. Everyone
Everyone cannot
cannot
able to
able
do
to do
this
this
grouting.
grouting.
Skilled
Skilled
labors are
labors are
required,
required,
so
so
more
more
training
training
needs to
needs
be
to be
given
given
when
when
the
the
labor
labor
is
is
going to
going to
do
do
the
the
grouting
grouting
technique.
technique.
Next one
Next
is
one
the
is the
soil
soil
stabilization
stabilization
technique.
technique.
It
It
will
will
it will
it will
take,
take
that
that
means
means
long term
long-term
performance
performance
enhancement. For
enhancement. For
example, if
example,
you
if
are
you are
adding
adding
lime
lime
or
or
something,
something,
immediate
immediate
performance
performance
enhancement will
enhancement will
not be
not be
there.
there.
But
But
if you
if
are
you are
using
using
this,
this,
some
some
environmental
environmental
concerns will
concerns will
be
be
happened.
happened.
So we
So we
need to
need to
take
take
care
care
of
of
that.
that.
So
So
key
key
findings
findings
from
from
these
these
things
things
are
are
it is
it
a
is a
tailored
tailored
approach.
approach.
That
That
means
means
specific
specific
conditions
conditions
are
are
critical
critical
for
for
effective
effective
ground
ground
improvement
improvement
techniques.
techniques.
Ongoing
Ongoing
research
research
and
and
innovations are
innovations are
essential
essential
for
for
advancing
advancing
these
these
ground
ground
improvement
improvement
methods,
methods,
as
as
well
well
as
as
collaboration
collaboration
for
for
sustainability
sustainability
is
is
required.
required.
For
For
example,
example,
engineers,
engineers,
environmentalists,
environmentalists,
and
and
policymakers
policymakers
must
must
collaborate
collaborate
to
to
make
make
this
this
sustainable
sustainable
solutions.
solutions.
Integration
Integration
of
of
new
new
technologies
technologies
also
also
required
required
for
for
future
future
directions.
directions.
So,
So,
overview
overview
of
of
this
this
biopolymer
biopolymer
stabilized
stabilized
soil.
soil.
So
So
we
we
have
have
completed
completed
the
the
introduction
introduction
of
of
the
the
ground
ground
improvement
improvement
techniques.
techniques.
So
So
now
now
we
we
are,
are
based
based
on
on
that,
that
we are
we are
saying
saying
that we
that we
need to
need to
use
use
a
a
better
better
sustainable
sustainable
material.
material.
So
So
as
as
per
per
our
our
topic,
topic,
we
we
have
have get
entered
entered
into
into
the
the
biopolymer
biopolymer
stabilized
stabilized
soil.
soil.
So
So
this is
this
the
is the
overview of
overview of
the
the
biopolymer
biopolymer
stabilized
stabilized
soil.
soil.
So
So
what
what
is
is
meant
meant
by
by
biopolymer?
biopolymer?
Biopolymer
Biopolymer
is
is
a
a
material,
material
that
that
means it
it
is a
is a
natural
natural
material.
material.
Okay,
Okay,
so now
so
we
now we
have
have
completed the
completed the
overview of
overview
the
of the
ground
ground
improvement
improvement
techniques.
techniques.
After a
After a
short
short
break, we
break,
will
we will
start
start
this
this
biopolymer
biopolymer
stabilized
stabilized
soil.
soil.
Thank you.
Thank you. Okay, welcome back to the session. Welcome back to the online lecture after a short break. So now let us start from the biopolymer, the role of biopolymer in the soil stabilization. First, let us talk about the biopolymer. Why we are choosing this biopolymer? It is an sustainable additive. Biopolymer is a sustainable additive. What are the favorable characteristics? It increases the viscosity of the fluids. It is having a bioclogging property. What is this bioclogging property? If you are mixing this biopolymer with the water or some fluid, it will become a gel. So this gel, what will happen? If it will arrest the void spaces and it will attract the loose soil particles get together, and the and it will clog the void spaces. It will increases the shear strength and it will reduces the permeability of the soil, as as well as it is an eco-friendly and renewable material. So the common biopolymers which we are using now are xanthan gum, guar gum, sodium alginate, galen gum, chitosan, and beta glucan. I have referred a few journals and I am giving it to you for the our presentation today, biopolymers in soil stabilization. So I have segregated the literatures for each and every engineering properties. First one, we will see the effects of biopolymer on the coefficient of permeability for different soil types for different biopolymers. If you see the first one, the soil type is clay silt. The author used the xanthangum biopolymer. The optimum biopolymer content is 1% and it reduces the permeability from 10 to the power of minus 4 to 10 to the power of minus 6. That means 2 folds of permeability, coefficient of permeability, it has been reduced. So this is the author Martin et al. Studied in his research. In his research, he have used two types of soil. One is clay silt, another one is clay sand. So he have used one biopolymer for clay silt and three biopolymer for clay sand, and he found the optimum biopolymer content as 1, 2, 1 and 1 for the respective biopolymers. So in the second one, the permeability has been reduced from minus 4 to minus 8, 10 to the power of minus 4 to 10 to the power of minus 8 centimeter per second. So next, Kachaturian et al. In 2003, he have used the three biopolymers, xanthangum, guargum and cytosan. He have used in the units of gram per liter. The soil type is Ottawa sand. After adding this xanthangum, it has reduced the permeability from 10 to the power of minus 2 to 10 to the power of minus 3, irrespective of the biopolymer. For cytosan only, it is decreased from 10 to the power of minus 2 to 10 to the power of minus 4. Next one in the other studies, Bauza et al., he have used the guargum for the silty sand and he have added the 18% kaolin also. The optimum biopolymer content is 2% and the permeability is reduced from 10 to the power of minus 4 centimeter per second to 10 to the power of minus 7 centimeter per second. So Chang et al. Used the gelangum for the poorly graded sand, and here we can see the permeability is reduced from 10 to the power of minus 4 to 10 to the power of minus 9. And the author Caballor et al. Used the xanthangum for the low plasticity clay, and the permeability has been reduced from 6.5 into 10 to the power of minus 7 to 1.2 into 10 to the power of minus 7. There is no decrease in the orders, but there is a small decrease in the magnitude. Next one. Likewise, different authors have used for the soils like high permeable, highly compressible silty clay, poorly graded sand, high plasticity silt, soft marine clay, and different biopolymers they have used. We can see the decrease in the folds. Here one fold decreased, here two folds decreased, here there is no fold decrement is there, but there is a small change in the number. Here also there is a small change in the number. That means a decrement in the number. Next one, Chang and Cho, they have used Korean residual soil and admixed with the beta glucan. Now we are concentrating on the strength parameters. So for the Korean residual soil, they have added beta glucan and the optimum content is 4.92 gram per kg. It increases the unconfined compression strength from 1050 kPa to 3225 kPa. Likewise, this author has studied the Fontainebleau sand by using the biopolymer agar and starch. The optimum biopolymer content is 1% agar, and for star pole it is 1%. It increases the cohesion from 0 to 240 kPa. Likewise, another author studied Korean residual soil, beta glucan, optimum biopolymer content is 0.25. It increases the shear modulus and decreases the permeability. So now we can take a quick look on the different types of soil and the different types of biopolymer content here. We can see the optimum range from 1% to 2%. Whatever the biopolymer may be, whatever the soil type may be, if you are adding it, it is increasing the unconfined compression strength. Here it is 440 kPa to 2540 kPa. Likewise, all the soils has been increased for the irrespective of the curing days. Likewise, for desert sand and poorly graded sand, as well as including the UCS, the cohesion value also increased. The strength of the 2% xanthan gum treated soil exceeds the cement treated soil by 38%. So this author recorded that the strength he compared with the biopolymer with the cement treated soil. The strength has been increased by 38%. Next, silty clay, marine clay, sand clay, they have used these different biopolymers and the optimum biopolymers is recorded here. Here we can see the deviatric stress is increased from 228.7 kPa to 550 kPa for 28 days curing period. And then the undrained shear strength is increased from 0 kPa to 2.2 kPa and 2.4 times higher compression strength when compared to the untreated soil. So likewise here C value is increased. Here the strength gain we can see in the 90 days curing period. So in another study, this author has taken one biopolymer and 3 different sand. So for all biopolymer, the optimum biopolymer content is 1%. The C value is increased from the initial value to a greater value. So we have seen this type of soils and this same type of biopolymer already. So from this we are concluding that if you are adding the biopolymer with the sandy type soil or some clay type soil or silty type soil, the strength also increasing. Now strength means the shear parameters also increasing, C value and phi value. So from this till now seen studies, that means the literatures, we are seeing that biopolymer soil mix can reduce the permeability and increase its strength. The optimum biopolymer content depends on the viscosity of the biopolymer solution and the soil type. The strengthening of the soil depends on the soil type, biopolymer content and the mixing method. Here the mixing method is an important thing. In the next slide we are going to see about the mixing method. These favorable characteristics of the biopolymer is opting us to choose the in situ soil into a good quality base liner material. So here from this slide onwards I am going to use this biopolymer additive soil in the liner application. Okay, so liner application means liner for the landfills. We will consider the application. So many applications are there. Pavement application is there. Foundation application is there. So I am going to consider this biopolymer amended soil as a liner material for the landfills. So from the slide onwards, we will consider this. So this biopolymer treated soil we can use to modify the in situ, any in situ soil into a good quality base liner material. So we will these are our objectives. So this objective is not required now. So we will see my research study. So the soil is selected from the Trichy district, Srirangam city of Trichy district in Tamil Nadu. So the selected soil is classified as poorly graded sand clay mixture. The soil is a sand and clay mixture. So its maximum dry density is 18.98 kilonewton per meter cube and the optimum moisture content is 10%. Its initial cohesion is 62 kPa and the angle of internal friction is 28. The coefficient of permeability is very high, that means 10 to the power of minus 3. It is in the range of 10 to the power of minus 3. So this kind of soil, if you want to make it into liner material means we need to increase this unconfined compression strength above 200 kPa as well as this coefficient of permeability we need to reduce to the range of 10 to the power of minus 7 centimeter per second. The initial value is 10 to the power of minus 3. So these are the various chemical compounds which is present in the soil in oxide form. So in the selected soil contains these chemicals: kaolinite, dikite, hemagglutide, alaphane, polygarsite, pargasite, cepheate and quartz. So these terms are depicted here and we can take a quick look on the peaks of the XRD characterization of the soil. So the biopolymer I have selected for this study is 3 types of biopolymers. One is xanthan gum, next one is guar gum, another one is the beta glucan. So why I have selected this means 3 types of, I have selected one bacteria derived biopolymer, another one is the plant based biopolymer, another one is the yeast derived biopolymer. So their chemical names are given here and the molecular structures are depicted here. Xanthan gum is white or light yellow in color, guar gum is creamish white, and the beta glucan is brown in color. Their molecular weight is depicted here, and the company where I have purchased this are noted here. So the main thing what we want to note here is xanthan gum is the anionic biopolymer, guar gum is the non-ionic biopolymer, as well as beta glucan is also a anionic biopolymer. So their chemical composition has been derived from the XRD characterization. Next one is I have taken two bentonite material. Why now bentonite is coming into the picture means for the comparison purpose. So already I have chosen one in situ soil. I have choose three different biopolymers. I am going to treat with these three biopolymers with that in situ soil. I will get some permeability value and the unconfined compression strength value. Then this bentonite is the conventional material. So if you in practice they will treat the in situ soil with some bentonite for making into the clay liner. So now after I am going to compare this both uh, biopolymer treated soil, that means biopolymer amended soil, as well as the bentonite amended soil. So these are the properties and the chemical composition of both bentonites. So the tests we have carried is viscosity of the biopolymer, index properties of the soil, compaction test, permeability test, unconsolidated undrained triaxial test, consolidation test, durability test. This test is very important for the application of liner. So the two durability tests we have done, wet and dry test as well as freeze and thaw test. So the microstructural characterization has been done by SEM analysis, FTR analysis, TGA. TGA means thermogravimetric analysis, as well as at last I have done a small model study for the biopolymer amended clay. That means which one is best. For that we have done the model study also. So this is that model study. I want to show you the dimensions and the equipment. So I have displayed here. It is a cylindrical tank of diameter 20 centimeter, height is 22 centimeter. It has the perforated plate fixed at 5 centimeter from the bottom, and we have fixed the filter paper over here. Above that we have placed a liner of 2 centimeter thickness. That means 1:500 scale we have fixed. So influent, we have poured the synthetic leachate above the liner material, and we are observing it in the bottom of this cylindrical tank. So what are the leachates we have applying here means cadmium, copper, zinc and lead. So the effluent is collected in the bottom tank and we will analyze. So the initial, what is the initial composition after passing, what is the final concentration, initial concentration as well as the final concentration we are going to check. So if the final concentration is reduced means this our liner is observing the heavy metals. So this is one of the heavy metal attenuation character is also one of the property of the liners. So how to prepare this sample? As already I have told you, the mixing method is important in the biopolymer. So we are having two methods. One is wet method as well as dry method, wet mix method as well as the dry mix method. So I am going to choose the dry mix method. So why I have choose this method in later we will see. So for example, different types of different quantity of biopolymer we will mix with the dry soil like this, and we will mix it without adding water. Then after blending it properly, then we will add the distilled water, then we will mix it again properly and we will make the biopolymer amended soil. Whatever the biopolymer may be, we have to add like this. Even though if it is xanthan gum or guar gum or beta glucan, we have to mix it. First we have to take the soil, we have to add the biopolymer and we have to mix without adding the water. So after thorough mixing, we need to add this water and we have to make this biopolymer amended soil. This soil we have to use it for the further sample preparation like permeability. So we will keep it in a Ziploc cover for curing purposes. For example, for doing 7-day test or 24 days, 21 days test and 28 days test, we need to preserve the samples in a airtight Ziploc cover for doing the test. So this is a sample image of the triaxial test samples. So both biopolymer and bentonite I have mixed with the dry mix method. So sample preparation of heavy metal solute for model study. So based on the different literatures where we have collected from India as well as all over the world, we have selected the concentration of the heavy metals. So cadmium, copper, zinc and lead will be in the concentration of 40.21 mg per liter. This is the initial concentration. So this metal cause extreme health risk for the environment and humans. So we are going to check whether the prepared liner will absorb this heavy metals or not in the final study for the best out of these three biopolymer for the optimum content as well as the which one is the best biopolymer. We are going to do this model test at the last. So viscosity study has been conducted. So the results are depicted here. Beta glucan is non-viscous biopolymer, so there is no change in the viscosity. For xanthan gum, if you are adding 0.25%, that means we have to take a distilled water, 50 ml of distilled water, and we have to add the corresponding biopolymer in this percentage. If it is 50 ml, 0.25 percentage we have to calculate. Answer will come in ml, you need to convert into gram. That much of biopolymer you need to take, you have to add it in the distilled water and you have to thoroughly mix it in the magnetic stirrer. So after making the homogeneous solution, we need to find out the dynamic viscosity. So the initial for 0.25 percentage of xanthan gum solution is 174 centipoise. The unit is in centipoise. So if you are for 2 percentage, it will increase 21 folds. It will increase, and the final answer is 3679 centipoise. Likewise, for guar gum also, it is increasing 300 folds from 12 to 300 folds it is increasing. For beta glucan there is no change. So you can see for different additives for 0.25 percentage, for 0.5 percentage, this red color indicates the guar gum and this green color indicates the xanthan gum viscosity. So this preliminary test results shows that wet mix procedure is not suitable. Why the wet mixer procedure is not suitable? See the see the viscosity of the biopolymer solution. If you are added this biopolymer in the water, this much high viscous solution we cannot able to properly mix with the soil. So directly we are adding the biopolymer powder on the soil, then we will add the water. So it will be very easy for doing the tests. So constraints in using biopolymer content more than 2%. Why the study is limited to 2% means after 2% of this biopolymer in the soil will tends to form like aggregates. So the study is limited up to 2%. So now we have getted into the index properties irrespective of the biopolymer. See this red color indicates xanthan gum amended soil, green color guar gum amended soil, blue color beta glucan amended soil. So the guar gum amended soil have more liquid limit when compared to remaining two biopolymers. For a limited content, we started with 38%. The untreated soil is having this 0%, mentioning the untreated soil. The untreated soil is having 38% of liquid limit. By adding 0.25%, it is increasing. At the finally 2% is increased to 70%. It shows that this biopolymer is gives the increasing the liquid limit of the soil. Even though if it is increasing the liquid limit of the soil, the further engineering properties needs to be checked. So not only the liquid limit, it is increasing the plasticity index of the soil. So see, for both guar gum amended soil is having more values. Second one is the xanthan gum amended soil. As the beta glucan is non-viscous in nature, the liquid limit and the plasticity index is very less when compared to the untreated soil. So the percentage change we can see here. So I have taken the maximum percentage. The liquid limit is increased by 36% for 2% xanthan gum amended soil, and the plasticity is increased by 29%. For guar gum amended soil, 80% of liquid limit and 111% of plasticity index is increased. For beta glucan amended soil, 13% as well as 13% liquid limit is increased, but the plasticity index is reduced because the plasticity is very less for after adding the beta glucan because it is non-viscous biopolymer. So whenever we are doing the study, we need to compare it with the previous studies also. Not only for us, in the previous studies also, by adding this biopolymer, the liquid limit and the plasticity index has been increased in the previous studies. So next one is the compaction characteristics. So compaction characteristics for the xanthan gum amended soil shows the two compaction characteristics. We need to discuss about two parameters. One is the maximum dry unit weight, another one is the optimum moisture content. So this picture depicts the maximum dry unit weight and the optimum moisture content of the unamended soil as well as the biopolymer amended soil. So this red color indicates the maximum dry unit weight and this green color indicates the optimum moisture content. By increasing our biopolymer content, there is a small change in the maximum dry unit weight. That means initial for a lower biopolymer content, there is a small increment in the maximum dry unit weight. By increasing the biopolymer content, the maximum dry unit weight tends to reduce in a limited content. So as the biopolymers are hydrophilic in nature, by increasing the biopolymer content, the water optimum moisture content is getting increased. The similar pattern is observed for the guar gum amended soil also, but the maximum dry unit weight is reducing abruptly. That means continuously, the trend seems to be continuously reducing. For beta glucan amendment soil, there is no that much increase because it is the non-hydrophilic in nature, and the optimum moisture content also there is no increase up to 1.5 percentage. Last 1.75 percentage and 2 percentage, there is a small increment. So now we can see the percentage change in maximum dry unit weight and the optimum moisture content. So for the 2% xanthan gum amended soil, the maximum dry unit is decreased only 1.63 percentage. When compared to it, guar gum decreased the maximum dry unit weight very less. So this maximum dry, why we need to compare this, why we need to analyze this result means if the maximum dry unit weight is decreased, that means from the initial, if it is decreased means it will get more strength. So next we will compare it with the previous studies. Some of the biopolymers, for some soils it is increased, for some soils it is decreased. So it is recorded in the previous literatures. So it is depend, this change in dry density is depend on the soil type and the viscosity of the biopolymer solution. So only we need to select the proper biopolymer for the particular soil. So the high viscosity solution separates the soil particles, causing a reduction in density. The optimum water content, if it is increases means when the biopolymer concentration is increased, the optimum water content also increases because it is hydrophilic in nature. So next we have come to the coefficient of permeability. This results I have depicted like effect of biopolymer type, effect of biopolymer concentration. First we are going to see about the effect of biopolymer type. So here we can see blue color is xanthan gum, red color is guar gum, and the green color is beta glucan. So our initial unamended soil value is 10 to the power of minus 3 centimeter per second. After adding 0.25 percentage, the xanthan gum values decreased to the fold of 10 to the power of minus 5, and the guar gum is reduced to the 10 to the power of minus 6, but the beta glucan value is 10 to the power of minus 5, in the range of 10 to the power of minus 5. Almost this xanthan gum and beta glucan is in the same range, but this guar gum has been decreased. So I am talking about the lower, even the lower biopolymer content reduces the permeability drastically. So now you see the irrespective of the biopolymer content, we have achieved the permeability which is required for the liner material, where we achieved for 1.75 percentage of xanthan gum and the 2 percentage of xanthan gum, we have achieved the liner material irrespective of the biopolymer. Only xanthan gum only achieved here. So next one, that is 1 day curing period. This result shows the 1 day curing period. That means the immediate curing. After adding the soil, 1 day the xanthan gum achieved the required value. So for 3 days curing, also xanthan gum only achieved. For 7 days curing, xanthan gum and guar gum has been achieved. So we have to check the standard curing days is 28 days curing. So if you are seeing the 28 days curing, irrespective of the biopolymer, up to 1.2, up to 1%, up to 0.75, that means lower concentration level, all the three biopolymers not met the standard. That means except xanthan gum, guar gum, beta glucan not met. So after 1%, all the biopolymer attained the required liner material value. So when compared to this xanthan gum has very less permeability value at the 2%. So likewise, I have done the test for 3 months, 6 months and 1 year also. So after 1 year curing, that means this is the major thing. So why it is a biomaterial, why we need to go up to 1 year? Because we need to see the degradation of the material. So after 1 year also, we can able to see that uh, all three biopolymers at the maximum concentrations are up to the mark. That means up to the mark means the required K value as per standards it is attained for the liner material. So from this we can say that we can use the biopolymer, all these three biopolymer for the liner material in terms of permeability. So in terms of permeability it is suitable. Next we are approaching the same coefficient of permeability in terms of biopolymer content. See here. So this color shows the different biopolymer concentrations. So this is curing time in days. So by increasing the curing time for different biopolymer concentration amended soils, the permeability is decreasing only. So at 365 days, that means 1 year curing, the lower biopolymer concentrations not met. That means 0.25, 0.5, 0.75 and 1% does not met the soil. But the higher biopolymer concentration starting from 1.25, 1.5, 1.75 and 2. These higher materials, higher concentrations attained the standard values. So from this we can say that the biopolymer amended soil can be used as a liner material in terms of permeability only. So now we need to see so this is for guar gum amended soils, this is for the beta glucan amendment soil. Same trend has been observed in the 365 days. So this is the effect of biopolymer content, how much folds it has been reduced, the values are depicted here. Next one is the effect of curing period. So by changing, so different colors has been given for the day wise. So this last color shows the 1 year and the first color shows the first 1 day curing. So for the maximum biopolymer content from 1 day curing to 365 days curing, it is in the standard level. But for less, we cannot see the same trend. For the less biopolymer content, we cannot see the same trend. So from 1.5, we can see the trend that it attains the standard values of for the clay liners. That means what is the standard value? 10 to the power of minus 7 centimeter per second as per US EPA. US EPA means United States Environmental Protection Agency. The liner material should contain the permeability value of 10 to the power of minus 7 centimeter per second. But the soil which we have selected is having only 10 to the power of minus 3 centimeter per second. So at the higher biopolymer content from 1.25, we have achieved these values irrespective of the curing days. So for guar gum amendment soil, we can see the results here. After the biopolymer content 0.5%, we are getting after 28 days, we are getting the trend values here. Next for beta glucan amended soil, from 1%, we are getting the trend values. So up to point that at the lower biopolymer concentration, we are not getting these values. From 1%, these are meeting the standards, but not for the earlier curing periods. That from 7 day onwards, this biopolymer treated soil attained the required K value. So next one, effect of curing period. See that in the effect of curing period, I have taken the maximum value only. We can see it is in the range of 10 to the power. That means it is less than 10 to the power of minus 7 only, irrespective of the biopolymer. So how this permeability is getting decreased? What is the mechanism? The mechanism is nothing but the bioclogging mechanism. See, I have drawn a diagram, the picture. So the soil type which we have selected is the contents of both sand and clay mixtures. So this soil grain showing sand, clay particles are also attached with the sand grains. So it has some wide spaces. So it is very free drain in nature for the water flow. So this is the untreated soil. So now I am going to add the xanthan gum. That means I am going to amend with xanthan gum. After amendment with xanthan gum, what is happening? The wide spaces are clogging with the biogels. So these gels, if you are sending water inside, the water movement path will be arrested. So only very low permeability. That means hard. It is very hard to drain. So only we are getting very low permeability for xanthan gum amended soils, as well as for guar gum amendment soil. We can see the biofilm and the soil will become aggregate. It will tends to attach with each other and it will form like aggregates. So the effluent cannot be able to pass easily. For beta glucan, what is happening is the soil and beta glucan getting interacted and clay particles get to absorbed with the beta glucan, and so the permeability has been reduced here. So this is the mechanism why the permeability has been decreased. So next, the same thing we can confirm with the microstructural study also. See here, this is the untreated soil. Many wide spaces are observed in the untreated soil because of the subangular shape of the soil grains. So now I have taken some images for all the maximum biopolymer content. That means 2% irrespective of the biopolymer. For different curing days, you can see here. For 1 day curing, the biopolymer gels threads are there. Then it seems to coat with the soil grains after 7 days. In one month, what is happening? Gel plugs are forming. In 2 months, aggregation of soil particles are happening. So in 6 months, we can observe the uh, partial drying of gel, and in 1 year curing you can see the shrinkage of gel. Even why we are getting the very less value at the 365, very less, not, it is not very less value when compared to the 7 days curing or 1 month curing. This 1 year curing permeability value is less because of the dryness of the gel. So the similar pattern is observed for the 2% guar gum amended soil as well as 2% beta glucan amended soil. So we are going to compare it with the bentonite amended soil. So the bentonite amended soil, the content has been taken from 10%, 20%, 30%, 40% of calcium bentonite as well as the sodium bentonite amended soil. So the initial value of the untreated soil is mentioned here. So this is the required K value. So when it attained the required K value for 40% only, both the calcium bentonite amended, both the calcium bentonite and the sodium bentonite amended soil reached the required value. So now we can compare with the 2% of xanthan gum amended soil, guar gum amended soil as well as beta glucan amended soil to the 40% of the bentonite, that means calcium bentonite amended soil as well as the sodium bentonite amended soil. So here permeability is reduced because of the bridging of soil particles as well as the aggregation of soil particles has happened at the 40% calcium bentonite amended soil. So the similar kind of results has been observed in the previous studies also for different types of soils as well as the different types of biopolymers. You can see the reduction in folds in the previous studies, 41, 375, 11. So in by adding 2% gel gum, we have observed more reduction in folds during the 7 days curing period, which is observed recorded in the Chang et al. 2016 studies. So next we have, as per the US EPA, not only the permeability, shear strength parameters also needs to be high. That should be more than 200 kPa. So now we have going to see about the cohesion and the angle of that means shear strength parameters. So the zero content is nothing but the untreated soil. Then this 0.5%, 1%, 1.5%, 2% of the xanthan gum content. So we have taken 3 curing periods. 0th day means the immediate effect, 7th day and the 28th day. So irrespective of the curing period and irrespective of the biopolymer content, the strength that means the cohesion has been increased. See the initial value is limited to 25 kPa and it has been increased to the for 2% up to 1600 kPa. So how much folds it has been increased, we will see in the next slide. Likewise, angle of internal friction is increased for 0.5% irrespective of the biopolymer and it has been decreased. So the angle of internal friction is diminishing because of the hydrophilic nature, because the gel is going to coat with the soil grains. So the soil grains tends to be very smooth and so the angle of internal friction is getting reduced. Next one, guar gum amended soil. For guar gum amended soil, the strength has been increased from 25 kPa to almost 1100 kPa for the 2% at 28th day curing period. This is the cohesion as well as the angle of internal friction in the when compared to xanthan gum it is diminished, but when this guar gum is not diminished, there is a small increment in the angle of internal friction. For beta glucan amended soil, the strength has been increased, but when compared to previous two biopolymer, it is less only. From in the maximum strength has been cohesion is up to 600 kPa. Here the maximum angle of internal friction is 50 kPa. The angle of internal friction is slightly increased. Next one, the enhancement in shear strength parameters. See, so now I have given in terms of folds how much cohesion is increased, how much angle of internal friction is increased. It will be very clear in the in the minimum day. That means immediate effect. If you are adding the 2% xanthan gum into this untreated soil, immediately 24 folds the cohesion has been increased. That means within 2 hours. But in the 28th day, it attains 54 times, 54 folds increased. So angle of internal friction also increased from 1.48 fold to 1.59 folds. So we can observe the remaining values here. Next, so we are keeping this SEM image for this micrographs for the 28 days curing period to showing the evidence for increase in strength. Why the strength has been increased now? That means the cohesion, why it is increased? Because for different, by increasing the biopolymer concentration, we can see the particle aggregation. So when it is 0.5%, only gel plug is there. But for 1%, 1.5%, 2%, that means by increasing the biopolymer content, the soil grains are tend to form like aggregates and the gel is accumulated over the soil grains. We can, that strength has been increased. That means the cohesion and the angle of internal friction. So due to this gel accumulation, angle of internal friction is reduced. Due to this particle aggregation, the cohesion is increased for the xanthan gum amended soil. But for guar gum amended soil, there is no reduction in the angle of internal friction. In the previous slide, we can see. Now, the gel coating and the particle aggregation is evidence from this micrographs. These micrographs are the 28 days curing period micrographs. So again, we want some other scientific evidence why this strength has been increased. We need to see the chemical compounds. Is there any chemical compounds formed for this strength increment? Yes, calcium silicate hydrate is formed. For to this green color represents beta glucan amended soil. This red color represents the 2% guar gum amended soils, and this black color indicates the xanthan gum amended soils. See, in this peak, in these two peaks, we have observed the CSH. CSH is nothing but the calcium silicate hydrate. This is a chemical compound which will increase the strength of the soil. So we are observed these chemicals after adding the biopolymer. So it is very clear that by adding the biopolymer, this calcium silicate hydrate gel will form, and this gel is the reason for increasing the shear strength of the soil. So we can compare the similar our results with the previous studies. In the previous studies also, strength has been increased this much drastically. Next one is the compressibility parameter. This compressibility parameter shows that for so this blue color represents the unamended soil, and 0.5%. So for different colors you can see here, different colors is given for the different biopolymers. Here the study has been conducted only for the lower biopolymer content as well as the maximum biopolymer content. So green color represents the xanthan gum and guar gum amended soil as well as the beta glucan amended soils. The term I am explaining now. So the values, so this picture seems to be clumsy. You can observe the values here in the table. For untreated soil, the compression index is 0.072. But when we are introducing the lower biopolymer content of xanthan gum amended soil, it is increasing. Further, if you are adding, it is further increasing. So this compression index is increasing. Why it is increasing means the biopolymer is a, when we are adding with soil, the soil becomes soft. So if the soil becomes, that means the nature, the tendency of the soil is soft, but the strength is not decreased. So only this compression index is increasing irrespective of the biopolymers. Next one is the compressibility. We are the same thing, same results we are comparing with the previous studies. In the previous studies also, uh, it has been increased, 5 times increased in one study for and 4 times, 1 times, and another 4 times it is increased in some other, that means Kabeler et al. 2018 studies. So what they are saying, this author what he is saying means, interpret that the change in permeability and consolidation values, it is could be due to the filling of pores between the grains. It is because of the filling of pore between the grains. What is filling in the pores? The gel is filling in the pores. So next we came to the wet and dry test. So I have done the test for 2% xanthan gum amended soil and 2% guar gum amended soil. Remaining soils has been dissolved. So this 2% xanthan gum and 2% guar gum amended soil shows the maximum retaining things. So you have after 12 cycles, after 12 wet and dry cycles, after 12 wet and dry cycles, 2% xanthan gum amended soil shows almost 4% weight loss. Guar gum amended soil shows 5% weight loss. So beta glucan amended soils totally collapsed after 2 cycles. So the volume change is given here. You can see the percentage increase above this line, percentage increase in volume. This shows the shrinkage in volume. So guar gum amended soil only volume is increased, but the xanthan gum amended soil, for first few cycles it is shrinked and for next cycles it is increased. Next one is freeze and thaw cycle. Freeze and thaw test. In this test, the procedure is given here. You can see. We will see the results only here. It is the study is limited. This result shows that the weight loss for the freeze and thaw study is also limited, less than 5% only. As well as in the previous slide also we have observed that the wet and dry cycle test also shown that the study has been that the weight loss is less than 5% only. So we can based on this wet and dry test and freeze and thaw test, we can say that the loss is very less for irrespective of the, by not very less, it is less than 5%. That is within limited period. Next one is the thermogravimetric analysis. Thermogravimetric analysis is nothing but we are going to keep the soil sample in that particular equipment. That equipment will increase the temperature from 0 degrees Celsius to 1000 degrees Celsius. So based on the increase in the temperature, how much the percentage of weight is getting decreasing, that only we are going to see here. So if you from 0 degree to 100 degree, the hygroscopic water will be removed. From 100 degree to 200 degree, bound water will be removed. From 250 to 450, humic components will be removed. From 450 to 1000 degrees Celsius, biodegradation will be happened. So this different curves showing the weight loss of different uh, soil, that means untreated soil as well as the biopolymer amended soil. So which biopolymer is having very less weight loss means uh, beta glucan amended soil has very less weight loss, but it is all the biopolymer content, the weight loss is less than 15%. Next one is the leachate study. So already I have shown you that cylindrical tank. In that cylindrical tank, we are keeping the 2 centimeter liner. Above the liner, passing the leachates. So the leachates initial concentration is here. That leachate contains four different chemicals, four different heavy metals, that is cadmium, copper, zinc, and lead. So this is the initial concentration. So in untreated soil, there is very less in the untreated soil does not absorb these heavy metals. But if you are seeing for 2% guargum amended soil, 2% xanthangum amended soil, 2% beta glucan amended soil, this beta glucan amended soil not at all absorbed the heavy metals, but this 2% xanthangum amended soil almost it absorbed all the things. See the results in table, you can see the concentration. 2% xanthangum amended soil, all the investigated heavy metals has been absorbed almost completely. This guargum amended soil is greater than 95 percentage, it is observed. That means almost in the values of 95 percentage. Beta glucan amended soil, very less only it is observed. So from this we can see that 2% xanthangum amended soil has a high strength. That means as per US EPA, it has the strength greater than 200 kPa, as well as the permeability also reached to the standard. That means 10 to the power of minus 7 centimeter per second. So this both xanthangum amended soil and guargum amended soil absorbed the heavy metals also. So we are recommending this 2% xanthangum and 2% guargum as a liner material. 2% xanthangum amended soil. That means for this particular selected in situ soil, if you are adding this 2% xanthangum and 2% guargum, we can use it as a liner material. So as already we discussed, we need to see the materials cost also. So the cost has been derived from the taken from the India Mart website. So see here the actual cost of the additives. So why I am comparing, we have done the bentonite study. Bentonite is the conventional material. Xanthangum, this biopolymer is the our biopolymer material, biomaterial. So now let us compare. What is the percentage? It shows a good result. 40% it shown the good result for the calcium bentonite. When compared to calcium bentonite and sodium bentonite, calcium bentonite showed the best result. So I have selected 40% calcium bentonite. When compared to all the biopolymer, xanthan 2% xanthangum showed best results in all the parameters. So I have taken this to soil, amended soil only. So see here how much soil is required. Here 2 ton is required. Here 1.9 ton is required. Here 0.8 ton of calcium bentonite is required. Here 0.03 because very less percentage, 2% xanthangum is required. So even the cost of the biopolymer is very more. We are going to use very only less percentage. Due to that, the cost of the additive of the biopolymer is less. But even the cost of the bentonite is less. The more quantity of bentonites we need to use to make it as a liner. So cost wise also this biopolymer material, the cost of the biopolymer material is high, but the quantity we can use very less only. So this calculation has been done for the 1 cubic meter of the treated soil. That means 1 meter by 1 meter by 1 meter. If you are treating, this much cost is coming. So we can say this biopolymer, this xanthangum biopolymer, not only the giving good results in terms of economically also it is very good. So this cost has been arrived based on the Tamil Nadu Public Works Department. This is the calculation. So now we came to the conclusion section. So in the conclusion, what we can say, we will start from the beginning. Dry mixing method is suitable for this study, for this biopolymer. So biopolymer dosage was limited to 2%. Why? Because after that we cannot able to handle the soil. It will become the aggregates types. So the main conclusion for the study already I have shown. The main thing is the hydraulic conductivity as well as the strength of the soil. So the hydraulic conductivity has been reduced. That means 10 to the power of minus 8 per centimeter second immediately in the 1 day curing. and maximum percentage shows the decrease in folds. That means 25 folds, 17 folds, and 10 folds increment in the C value, and phi value is increased 1.5 folds, 1.6 folds, and 1.8 folds. The strength also has been increased. So the maximum confining pressure applied to the biopolymer amended soil is limited to 200 kPa, in line with the confining pressure generated by the average height of the solid waste dump in the field. So this is one of the important point why we have used the 200 kPa, limited to 200 kPa means this confining pressure. If you are applying this 200 kPa in the real time field, what does it means? We are dumping the solid waste up to 15-meter height. So if you are fixed this 200 kPa in the laboratory, why means in this above the liner we can able to dump the solid waste up to 15-meter height. So in the laboratory, that condition we are maintaining in the laboratory by keeping the 200 kPa. So the full study is conducted, the triaxial study is conducted maximum of 200 kPa. So the, as already we discussed, the compression induction also has been increased. Also the xanthangum and gorgum treated soils shows better durability. The leachate attenuation capacity shows very high attenuation in 2% xanthangum amended soils and appreciable for 2% gorgum amended soil. The 2% beta glucan amended soil shows the least performance. So the above test results show that the 2% xanthangum amended soil can be used for the construction of compacted soil liners for the solid waste landfills. So these results are limited to only the selected soil. These results may be varied for the other different soils. So this, what are the future scope for this additional research? So these results can be, the study can be further used for the future research. So the behavior of the liner material under the real time leachate can be further studies, because this lecture series is for the what are the recent research trends. So this is the very important, because we are in the conclusion section for the research scholars, for BTech scholars or MTech BTech students as well as the MTech students, how you can take this study, use this biopolymer means you can use the real-time leachate. So what I have used is the synthetic leachate. So the real-time leachate we can further study, as well as the various environmental studies like diffusion and sorption test can also be performed. We have limited the studies here in our studies. The biopolymer amended soil can be further examined to use as a final cover material. Now we have used for the liner material, we can study it for the final cover material also, their performance in the composite liner system. That means geosynthetic clay liner. So we can sandwich this sample with the geosynthetic material, and then we can use it as a composite liner system. The study can be further extended to fabricate the geosynthetic clay liners, just now I have said, as well as this biopolymer amended soil can be further used in various geotechnical applications like soil erosion control as well as the slope stability. So these are the references I have used for making this presentation. If there is any queries, you can text in the text box. Now, I would like to give acknowledgement. Few of the initial slides has been generated by the AI tool Canva. So if any queries is there, you can send the mail to my mail ID. My mail ID will be displayed in, sent to the chat box. Dr. Suman sir will send my mail ID in the chat box. So I would like to conclude this section by saying the thanks for all the participants, those who are attending this session patiently for the past 1.5 hours. So now we will share the feedback link as well as the quiz sheet to your WhatsApp group. You can you can answer the link in the, you can answer for this quiz as well as you can fill the feedback form. Okay, thank you for all the participants. Once again, thank you.